In this lesson we will look at the relationships between sets. The first relationship that we will look at is called a subset. Consider two sets A and B which are non-empty, and if all the elements of A are present in B and all the elements of B not necessarily are present in A, then A is called the subset of B and it is represented with the symbol subset. So let's look at an example. A equal to 1, 2 and B is 1, 2, 3, 4. As you see here, all the elements of A, 1 and 2 are present in B. So this is a good example of A subset B. Similarly, A equal to strawberry, orange and B equal to watermelon, banana, strawberry, pear and orange. And as you see, we have strawberry and orange even in the second set, which is B. And not necessarily all the elements of B are in A. So this is also a good example of A subset B. Similarly, we have A equal to Delhi, Paris, Rome and B equal to Delhi, Paris, Rome. Again, all the elements of A are present in B, and here all the elements of B are also present in A. So even this is a good example for A subset B, but this is also a good example for two equal sets because they have the same elements. And an important property to remember is an empty set is always the subset of every set. One thing with the empty sets is some books actually represent the empty set with this symbol, but this is not really correct because this is a Greek letter pi and this is often used to represent empty sets in some literature, but the actual correct representation of an empty set is this symbol, a circle with a cross slash like this. The next relationship that we will look at is called the power set. The power set of the set A is the set of all possible subsets of that set A, and it is denoted with P of A. So let's look at an example. A equal to 1, 2. So what are the all possible subsets of this set A? So to begin with, we have previously learned that an empty set is a subset of every set. Empty set is the first subset of this set A, and then this set has two elements, 1 and 2. So if you consider 1 alone as its own set, this unit set is a subset of A. Similarly, considering 2 by itself as in a separate set, again this is also a unit set because its cardinality is 1, is a subset of the set A. And finally, considering the set by itself is also considered as a subset. So every set is a subset of its own set. So the number of subsets here is equal to 4, and the number of elements or the cardinality of this set is 2. So we can generalize this as if n is the number of elements in the set A, then the number of elements of the power set is equal to 2 power n. So here n is 2, so the number of elements in the power set is equal to 2 square, which is 4. So the next type of sets that we will look at are called equivalent sets. So two sets A and B are said to be equivalent if they both have the same number of elements. In other words, two sets are said to be equivalent if n of A is equal to n of B, right? N of A is nothing but the cardinality of the set. Cardinality of the set is nothing but the number of elements of the set. So pretty much two sets A and B are called equivalent if they have the same number of elements, and they are represented with this symbol. So let us look at few examples. So here we have been given A equal to 1, 2 and B equal to 3, 4. These two sets are equivalent because they have the same number of elements. Similarly, A equal to a strawberry and orange, B equal to a watermelon and a banana. These two are also equivalent because they have the same number of elements. Similarly, A equal to Delhi and Paris and B equal to Delhi and Paris. Both sets have equal number of elements, and also if you observe here, they are the identical sets because they have the same elements as well. So an equivalent set can have same elements. So finally, there is another set, A equal to strawberry, orange, B equal to watermelon, banana, strawberry, orange. If you observe, the cardinality of the set is 2 and the cardinality of the set is 4. So these two are not equivalent sets. And the next relation we will look at is the equal sets. Two sets X and Y are said to be equal if they have the same elements, which is, in other words, if all the elements of X are present in Y and if all the elements of Y are also present in X, if X subset of Y and Y subset of X, then X is equal to Y. Let's look at few examples. A equal to 1, 2 and B equal to 1, 2. So if you observe here, all elements of A are present in B and all elements of B are also present in A. So A is equal to B. Similarly, A is strawberry orange and B is also strawberry orange. So these two are equal sets. Over here we have Delhi, Paris, Rome and as set A and Delhi, Paris as set B. Here these are not equal sets because A has Rome and B doesn't have Rome. So B is a subset of A, but A is not a subset of B. So these two sets are not equal to each other. So let's look at the final example. Here we have been given 2, 4, 6, 8, 10, so on. And in another set where we have been told X is such that X is an even natural number. So A is nothing but a set of even natural numbers, as you see, 2, 4, 6, 8, 10, so on. So this is a raster form and this is the set builder form of the same set. So these two sets are also equal. The next set relationship that we will look at is called disjoint sets. Two sets X and Y are said to be disjoint if there is no element common to each other. In other words, if X intersection Y is an empty set, then those two sets X and Y are called disjoint sets. We will learn about intersection of sets in the next lesson. But for now, remember this, that X intersection Y is an empty set, then X and Y are disjoint sets. And this is the symbol that we use to represent intersection. So let's look at here. A equal to 1, 2 and B equal to 3, 4. There is no element which is common to both the sets. So A and B are disjoint sets. Similarly over here we have strawberry and orange in the set A, and in the set B we have watermelon, banana and pear. So no elements in common. So A and B are disjoint sets. Lastly we have Delhi, Paris, Rome and Delhi, Paris, Rome. Right? These are equal sets. So they have all the elements in common. So these two are not disjoint sets. They are equal sets.